Alright, so today we're looking at complex numbers, trig identity. Okay, so last lesson I took you through a HSC past question. Alright, now the good of that will be hopefully things that we're looking at today will become a bit more sense, okay, with how things are coming along. Maybe I should have done this first before I've done the HSC question, but we'll see how we go today. Alright, so let's start expressing. So what we're going to do is use what we know in complex numbers already and start looking at deriving some trig results, okay, including some you already know. Well, you should already know, I should say. Okay, so we want to express cos 2 theta, sin 2 theta and tan of 2 theta in terms of cos, sin and tan of theta. Okay, so cos 2 theta plus I sine of 2 theta. Okay, using the Swivl theorem, going back the other way, this becomes a cos theta plus I sine theta all squared. Okay, to go backwards on the Swivl theorem, then we're going to expand that square. So cos squared theta plus I sine theta cos theta, take away sine squared theta, because I squared is negative 1. Sorry, I've got 2 for the middle term, double it. Okay, and we match the real parts and the imaginary parts. So cos, cos of 2 theta is going to equal the real part of that side. Cos squared theta, take away the sine squared theta. That looks familiar. And we did trig in prelim course. Yeah. Yep. Tension 1, trig.
No, is it 1?
Sorry?
Is it 1?
No. Sine squared plus cos squared is 1.
Negative 1.
No. No. And that's the result that we did in extension 1 trig. Double angle. That's the result. Okay. And the imaginary part, so sine of 2 theta is going to equal the imaginary part on the right hand side. So 2 sine theta cos theta. That also looks very familiar.
That's 1.
Hey, why are you saying 1? Sine squared plus cos squared is 1. We have done this in, yeah? Double angle results?
Is it just sine theta?
Hey?
Sine 2 theta?
Yeah, that's sine 2 theta.
Yeah. That's it, isn't it?
That's it, yeah.
And what are we trying to figure out?
No, I'm deriving cos 2 theta sine 2 theta in terms of sine and cos theta using your complex number skills rather than trig skills. Okay? Now, 10. 2 theta. What's my first line going to look like?
1 plus 2
10. 1 plus 10 theta.
minus.
Theta. So it's 10, 1 plus 10.
It's 1 plus sine theta? No. 10 theta over 1 plus 10.
That's it. That's it.
No.
It's close to it.
Close.
1
Close.
plus.
I'm trying to think of the identity like it.
Yeah.
1 plus 10.
Substitution.
1 plus 10 squared theta.
No.
Is it 10 theta? Is it 10 on top?
There is a 10 on top, yes.
1 minus 10 theta over 1 plus 10 theta?
Partly right. Okay, so we're getting to the end result, okay, but if we need to do that, we need to know, remember that tan is sine over cos.
Those.
Yeah. Equals 2 sine theta cos theta. I'm pretty sure I proved it this way in extension 1 trig as well. Cos squared theta minus sine squared theta. Remember what we did next? So?
Expand that bottom term and then get rid of this 2 sine theta cos theta that comes out of it.
You could do it that way, but it's probably going to create more of a mess for me later on. Everything by cos squared theta. Every tan divided by cos squared.
1 minus tan squared theta
For the bottom, yes.
over 2 tan theta.
Pardon?
Over 2 tan theta.
Other way around, so 2 tan theta over 1 minus 10 squared theta.
I was going to put them up.
That's what I'm saying. You said 1 minus 10 over 2 tan theta. Okay, that will be cot 2 theta. Okay. Okay, so formally, okay, these all cancel, and we know sine and cos is 10. So the result is 2 tan theta over 1 minus. Now it's a minus because 1 plus tan squared theta is,
1.
the one with the tan is sexy. Sec squared theta. Okay, so that's why you need to have your 1 minus on the bottom. Okay, and that looks familiar as well. Okay, so we can use complex numbers in de Moivre's theorem to derive complex numbers, okay, as opposed to doing the expansion of trig identities. Right. So cos 3 theta, sin 3 theta, and tan 3 theta in terms of sine, cos, the tan of theta. Okay, so we're going to go about the same way. Right, so cos 3 theta plus I sine 3 theta. What did we do first up on the previous question? What did we write on the right hand side? Using de Moivre's theorem, what do we do? Cos theta plus I sine theta. The brackets will magically appear in a moment. Oh, disappointing. Okay. Now we have learnt the skills how to expand this now.
Isn't it cos 2 theta plus I sine 2 theta take away 3 cos squared,
Definitely on the right track.
cos squared theta plus I sine theta plus 3 sine squared plus 3?
Yep. So, yep, you're on the right track. The 1, 3, 3, 1 for the coefficient of a cubic expansion. Okay, plus 3i cos squared theta sine theta. So decrease this power by 1, increase this power by 1 as you go from left to right.
Is that a sine squared theta?
Sorry?
The middle term? Is it a sine squared theta? No. Is it? Yeah.
Now, yeah. Now or the previous time? So this will increase in power by 1 going left to right, and this will decrease in power by 1 going left to right. Okay, if you don't remember that, we need to set out more formally your binomial expansion. Okay, this is under assumed knowledge that you know how to do this. Okay, and you can do this in your assessments and exam because anything in Mathematics Intention 1 will be treated as assumed knowledge. Okay, only the specific skill in extension 2 you will need to show more detail of, alright, to get your full marks. Alright, so we have cos cubed theta plus 3i cos squared theta sine theta. Now we've got I squared here. Alright, so it becomes a minus 3 cos theta sine squared theta. And then I cubed. What's I cubed? Negative I. Alright, so minus I sine cubed theta. Okay, I'm pretty sure we had a question where we did the expansions of triple angles result from memory. I can't actually remember. Okay, so cos of 3 theta. Okay, this is the real part, so it's going to equal the real part on the right hand side. So cos cubed theta okay. Now, I can represent this purely as cos, okay, because you all should be both be able to show me what the substitution for sine squared is in relation to cos. Alright, but I've answered the question. We need to just represent it in cos, sine and tan theta, what I've got there. Okay, and sine 3 theta. So this is the imaginary part of this side. It's going to equal the imaginary part of the expansion on the right hand side. So it's going to equal 3 cos squared theta sine theta minus sine cubed theta. And again, if I need this purely represented as sine 3 theta purely in sine theta, okay, I can manipulate cos squared theta using sine squared plus cos squared is 1. Expand it out and I'll have an expression just relating to sine theta, okay? But I have answered the question. You need to express cos 3 theta, sine 3 theta and tan 3 theta in terms of those 3 variables, which is what I've got. Okay, so tan of 3 theta. So what's my first line here? No. What did I do last time? So sine 3 theta over cos of 3 theta. So equals 3 cos squared theta sine theta, take away sine cubed of theta, all over cos cubed theta minus 3 cos theta sine squared of theta. Wow. Just let it out.
Look up the black line. That's the first step.
Okay, so what did I do from the previous question when I had to represent tan 2 theta? Okay, so what I'm going to divide by? Cos squared, just cos squared. Divide everything by cos cubed theta. Just let it go, Robin. Okay, so each term is divided by cos cubed theta. And then we cancel. So, give me 3 tan of theta, take away tan cubed of theta, all over 1 take away tan squared theta. Take away 3 tan squared theta. Okay, slightly different. But the approach for tan 2 theta, tan 3 theta are exactly the same, and I can do the same thing for tan 4, sine, cos and tan 4 and so forth, okay, by using the de Moivre theorem and matching up my real and imaginary parts. Alright, questions? Okay, so show that x equals cos of pi r 9 is a solution to that polynomial. Okay, hence evaluate that.
Just chop it.
That's essentially what we're doing, yeah. Essentially, but a slight different step involved. Okay, so the question 8x cubed take away 6x take away 1 is 0. So I'm going to factorise a 2 out of the first 2 terms. Put the 1 on the other side. So if we let x equal cos of theta, and the reason why I factorise that 2 out, because inside the bracket I have 4 times cos cubed of theta, take away 3 cos of theta. I've already seen that today, haven't I? Probably have. Have a look up above. Oh, because I haven't finished up. That's what I wanted to do. Okay, number 1 from the previous page. So we have cos of 3 theta, which is cos cubed theta minus 3 cos theta sine squared theta on the previous page for the result of cos 3 theta equals cos 3 theta take away 3 cos. What's sine squared theta equal to? Yes, just using your sine squared plus cos squared equals 1 identity. 1 take away cos squared theta. That's why I wanted to do it before. So the previous answer was correct. I did answer it in terms of sine and cos, but when you need it purely in cos, okay, expand that side out, tidy it up. Okay, so now we have finished that question. And that's what I've got in the bracket. Okay, so call this number 2. So put that into number 2. So 2 lots of cos 3 theta is equal to 1. Okay, so go back to your, well, mathematics even, solving for that. Okay. Just your trig makes the angle result, not your complex number application. Okay, we don't have any complex numbers here. Right, so what's angle, cos what angle in the first quadrant makes half? 60 degrees, which is pi on 3. Okay, quadrants, all students take calculus. Right, where's cos positive? Okay, because this expression is positive, that means cos is positive in the first and fourth. Okay, so 3 theta is going to be pi on 3. And then angle in the fourth quadrant is 360, which is 2 pi. Take away the basic angle. Okay, now I have a cubic polynomial. How many roots am I expecting? 3 of them. So I'm going to actually set up a third one. Okay, so we're going to complete revolution, so we get 2 pi plus pi on 3. Okay, where the next root would be. Okay, so to get theta by itself, right, so I need to divide all those by 3, so it becomes pi on 9. So 6 pi on 3, take away pi on 3, which is 5 pi on 3, and then bring the pi, the 3 just down, sorry, so it'll be 5 pi on 9. And then 6 pi on 3 plus pi on 3 becomes 7 pi on 3, and then bring the 3 down, which is 7 pi on 9. Now the trick here is because I'm looking at the second part of the question, okay, pi on 9, 2 pi on 9 and 5 pi on 9. Right, I've got 2 of those 3.
7 pi on 9 be greater than 9?
So?
Wouldn't 7 pi on 9 be greater than 9? Go right down.
Yeah. Yep. That's what I'm saying. I'm setting it up and then we're going to deal with that in a moment. We'll get there. We'll get there. Alright. So we'll now just for that first part we'll need to show that x equals cos pi on 9. So therefore if the theta is pi on 9 and we've already set it as cos, so therefore cos of pi on 9 is a solution. Right, so the hence. So the word hence means you should be using what you just used or other part of the question. Okay, if you really wanted to, you could go adventurous and do your own thing. So we need to now go cos of pi on 9, cos of 5 pi on 9. What was it? So 2 pi on 9 and cos of 5 pi on 9. Okay, now matching up to here, we've got pi on 9, and we need 5 and 7 pi. So we've got 5 pi on 9, we've got pi on 9, and now we need to do something about 7 pi on 9. Okay, so what is 7 pi on 9 in degrees? To help you thinking here. So?
140.
140, yep. So, thinking about your cos curve, 140 is going to be here, roughly. Okay, what's going to be the equivalent angle when we consider it as an odd function?
What's in the middle? What number's in the middle of 1?
Cos of 90, so cos of pi on 2. And if we go 50 degrees that way, all right, we need to go back 50 degrees this way because of the symmetry of your cos curve.
Wouldn't it be symmetry the other way? Because it's coming down, so you think here's symmetry.
Yeah, but with a negative sign.
But do we not want negative sign?
So going back to Friday's example, cos of 100 would equal to negative cos of 80. Okay, because cos of 100 will give you a negative value for y, correct? Okay, if I go negative cos of 80, that will give me that same value because I put the negative sign and because we're going 10 degrees on every side because of symmetry.
Is there symmetry on the right hand side though?
And that too, yes. So what's this point here?
180?
That's 180 here.
270?
Okay, so it'll be 3 pi on 2. Right, so if I go cos of 10 degrees this way, it will equal cos of 10 degrees that way.
So is it 210? 220?
220.
Yeah. Up to... Okay, so it's 90 on the
Yep.
cross point,
Mhm.
and we've got 140
Yes, which is 50 degrees this way, correct?
degrees that way.
So if I go from this point 50 degrees that way as well, yes. But that will be equal, the cos of 140 will equal cos of 220, yes? Okay, because of the symmetry with the axis here, alright, this end point, if I go 50 degrees this way, it's going to equal the negative of going 50 degrees that way because of the symmetry of the cos curve. Get your calculator out.
Oh, I believe you.
Hey,
I believe you.
okay, so if I put cos of 140 and then cos of 50 in the negative cos of 50 in the calculator, I'll get the same answer. Okay, because we're really considering what's the y value. That's 1, that's minus 1. Okay, so I can do that, and because I know that cos and sine curves provides me with symmetry. Okay, so what is 90 take away 50, which is 40, so what's 40 degrees in radian? Now let me help you out. What is pi on 9 in degrees? So if I need 40, so if I need 40, I need 2 pi on 9. And that's what we know. Here, okay? So, but cos of 5 pi on 9 is equal to negative cos of 2 pi on 9 because of the symmetry. Okay, you think about this part of the curve here. If I rotated that 180 degree, I'm going to get that same curve there. Okay, and if I put a negative sign here because they're on opposite side of the x-axis, these two values must be equal. Okay, so that's what I need. Alright, so negative cos, so just putting that minus sign right at the very front, pi on 9, cos of 2 pi on 9, and cos, hang on, let's do it more formally, with my roots. Okay, so these are my 3 roots here. Okay, so if I write down my 3 roots, so cos of pi on 9, cos of 5 pi on 9, cos of 7 pi pi on 9. So there are my three roots that I've got from setting up there. Okay, and cos of 5 pi on 9 is equal to negative cos of 2 pi on 9. Okay. So, equals negative cos of pi on 9, cos of 2 pi on 9, and cos of 5 pi on 9. Okay, so just putting that minus sign out the very front. Okay, this is the product of the three roots. Okay, so what have we done in the past to write the product of three roots?
Oh, it's just the
Okay,
sum of roots 35.
yeah, okay. How many, what's the degree polynomial?
3.
3. So we have sum of the roots 1 at a time, we have sum of the roots 2 at a time, and we have sum of the roots 3 at a time. Okay? The sum of the roots of alpha is going to be negative b on a. Sum of the roots 2 at a time is going to be what? C on a. And sum of the roots 3 at a time is? Yeah. And that's what the product of my three roots here must equal.
But there's no b.
So what is D?
It's like probably need after that.
So what is D?
0. 1. No 1. Yes, 1. Negative 1.
Yeah.
Negative 6.
Negative 1. Alright. A, there's no B.
Yeah, 1.
There's a C and there's a D. You've got to be careful. Alright. So give me negative 1 on 8. So 1 on 8. When you take care of your sign.
So we done?
Hey.
We done? Is that okay?
Oh, not technically, because it did ask you for cos pi on 9, cos 2 pi on 9, and cos pi over pi. I've got the negative of that.
Plus the negative.
So it's going to equal negative 1 over 8. Okay? So therefore, cos of pi on 9 cos of 2 pi on 9 cos of 5 pi on 9 is equal to negative 1 over 8. Right. Question. Did that make sense?
I understood that one.
Yes.
I wouldn't be able to replicate it, but I understood what you did.
Well, this is now the second or third question done of this similar nature, so I'm hopeful the idea that I'm showing you that you are starting to get that thinking along that direction, and then hopefully you'll be able to make the connections when you do your own question, okay? And of course, like you know, I'm always around to help you,
In the exam.
always. Hey,
In the HSC exam.
I will
Can you
be...
stand there next to
I will be at the front door and I will give you your final words of advice for your final exams
You're not allowed to be
in there.
No one like that.
Okay, a couple more things we need to do. Is the polar form of a complex number with modulus 1. Okay, find the value of Zn plus 1 over Z to the n and Zn take away 1 over Zn. So these are results that you need to know. Okay, so we're going to derive them.
So we have to know these.
Hey?
We have to know these.
Yeah, well, these results here. Okay, but I'm deriving them, right, so that you've got the opportunity to be able to derive them. Okay. Alright, so I know Z is cos theta plus I sine theta, so Z to the n is going to be cos of n theta plus I sine of n theta using my de Moivre's theorem. Okay, so Z to the n equals this, all to the power of n, then use your de Moivre's theorem. Okay, I think that's pretty straightforward now, so we don't have to formally step by step our instruction. Okay, so I need Z to the n. I've got Z to the n. I'm going to be able to write 1 over z to n in a moment. Actually, we'll do that now. Alright, so 1 over z to the n. What's another way I can write that? Just this, looking at this. Yep, so z to the negative n, good. Okay, and again, using de Moivre's theorem, it's cos of negative n theta plus I sine of negative n theta is equal to cos of n theta take away I sine of n theta. Why? And yes, I have shown you this before.
Is it because cos of negative, your addition and subtraction of sine and cos take away sine is cos x plus y, that sort of thing.
That sort of thing, yes.
Cos x, cos y plus sine x, sine y, the negative.
Yes, but we're going to do a much more simple approach to what we're doing here. Yes, you are correct, but there's a much more simple approach. What type of function is the cos function?
Odd.
It's odd. Because you've got symmetry about the y-axis. Sorry. No, it's even. Symmetry about the y-axis is an even function. Alright, just like your parabola. Okay, so the parabola is an even function because you've got symmetry about the y-axis. So the cos curve, you also have symmetry about the y-axis. So it is even. So f of x equals f of negative x. Okay, where your function is, where f is going to be cos. Alright, now your cubic, okay, is an odd function because there's a rotation of 180 degrees. Okay, and that one is f of negative x is equal to negative f of x. Going back to your mathematics function work. Alright, so I've got a negative angle for the function. Alright, so that means I've got the positive equivalent with the negative sign out the front, which is why I was able to do that. Yep. So, z to the n plus 1 over z to the n. Alright, so we've already got z to the n. So cos n theta plus I sine of n theta plus 1 over z to the n, which is what we've just written there. Okay, so even odd functions helps you a lot with this sort of work. Plus your cos n theta take away I sine of n theta. What does that tidy up to?
Cos n, 2 cos n theta.
Yep, because the I sine n theta cancels because you've got plus and minus. Alright, so you've got 2 cos of n theta. Okay, so a complex number to the power of n over, add the reciprocal of that same complex number, that's your result. Okay. Now, z to the n take away 1 over z to the n. Alright, so z to the n is cos n theta plus I sine of n theta. And then you need to take away the result we just derived. So take away cos of n theta, take away I sine of n theta. Okay, now because of the minus sign, the cos will be the one that cancels this time around. So it's going to equal 2 I sine n theta. Okay, so these are in your notes, okay? That's what you need to know. It's fairly straightforward to derive using the de Moivre's theorem in your notes. And also the cos and sine for the odd and even functions. So cos of negative x is also cos of negative x is equal to cos of x, and sine of negative x is equal to negative sine of x. Okay, because this one is even and this one is odd. Okay, questions on that? Last question I've got for you today. Express cos cubed theta in terms of cos n theta. Okay, and the reason why we derived that result from the previous page is we can use it very quickly in this question. So we know that 2 cos of n theta from the previous page was z to the n plus 1 over z to the n. So the addition is the cos, the subtraction is the sine. Alright, now if I cube both sides, there, because I actually know, and also n is 1, because there's nothing in front of theta. Alright, so I'm going to set n is 1. So this becomes an 8 cos cubed theta. Okay, it's equal to z plus 1 on z to the power 3, so just removing the n's there. And again, we've got a cubic expansion we know how to do now. Alright, using binomial, binomials work. So z to the power 3, net coefficient is 3. This squared, this to the power of 1. Okay, so this becomes negative 1, 2, take away 1 is 1, so it is 3 to z. Okay, and we're decreasing by 2 each power. Okay, so this becomes 3 over z plus 1 over z cubed. Recognising the pattern and following it. Alright, so I'm going to match this z cubed plus 1 over, I'm just reordering it because I'm going to use this result, what I've just done previously. Okay, plus 3 outside of z plus 1 over z. Okay, and that's the result. Z to the n plus 1 over z to the power of n is equal to 2 cos of n theta. And I've got it set up in this, I just now need to go back the other way. Right, so n is 3, so this is going to become a 2 cos of 3 theta plus 3 outside the front of 2, and n equals 1 here. Alright, so I'm going to put n is 1 here. Am I done? Why not? Okay, we've got 8 up here. And I've got it, n theta, cos of n theta. This is n theta, and that's n theta as well. Different values of n. Alright, so all I need to do now is bring the 8 down. So therefore, cos cube theta is going to be cos 3 theta on 4 plus 3 cos theta on 4, once you simplify your fraction. Okay, so that's the application. You can do similar sort with sine and different powers as well. Okay, so I can go back to my original question when I had sine cubed, sine squared, cos squared and all that sort of stuff. Okay, I could use this result as well. Right, that's it. Any question?